Okay, so have a look at this question, see what you think, pause the video, and you can try it. It's one of the first times we are going to try and use what we know about logs to help us solve real life situations. So this question says a population of bacteria grows exponentially according to the model, and it tells us the formula P is equal to 600 e to the power of 0.1144 t, where t is measured in minutes. So it says, what is the size of the population at time t equals 0? So all we have to do there, okay, so for part 1, all we have to do is fill in t as 0. Okay, so we have the formula P, the population, is 600 e to the power of 0.1144 t. Now t is 0, so whatever's multiplied by 0, my answer is just going to end up being 0 there. Okay, so e to the power of 0, what's anything to the power of 0? Well, it's just 1. So my population at t equals 0 is 600. Okay, what about the next one where it says where t is equal to 10? So try that. P is equal to 10. So it's the exact same thing. The population P is 600 e to the power of, and when we multiply this out, okay, really I should show what I'm going to multiply first. So 0.1144 times 10, just to be certain that you can see what I'm doing and that an examiner can see what you're doing. Okay, so that's going to give me 600, and let's look at what e to the power of 1.144 is. Okay, so when we do that, we're going to get 3.139, and the number goes on. So what I'm going to do is, I'm not going to try and write down the full number on my page, but I'm not going to delete it in my calculator. So when the number is up on my calculator screen now, I'm just going to multiply it by 600. And I see that my answer there is 1,883.58. Okay, so we want how many full bacterias, so just round that to the nearest whole number, so 1884. Okay, and then the last part, part 3, says find the nearest minute the time at which the population will have grown to 6,000. Okay, so the population is P, so I'm going to fill in P as 6,000. Okay, so 6,000 is equal to 600 e to the power of 0.1144 t. Okay, so, oops, no idea what I just done. So, we need to start figuring out how we're going to get t here. Okay, there's no point in starting to use the rules when I've got a coefficient on the e. Okay, but look at this. There's a bit of a hint in how similar these numbers are. Okay, if I've got a coefficient, it's multiplying all of this. So I'm going to divide across by 600. Okay, to get rid of the 600 coefficient. Okay, and it's so similar to 6,000, it kind of almost helps you make that link in your head. Okay, so I'm going to get that 10 is equal to e to the power of 0.1144 t. And we have to try and figure out, okay, the unknown here is in the power. So we have to try and figure out how to get this. So we said when there's a variable in the power that we're trying to solve for, we actually use the log loop and write all of this with our logs. So remember that log with a base a of y is equal to x. Okay, if and only if a to the power of x is equal to y. So I am going to use this idea to rewrite this in log form. Okay, so A is what's on the base of the power. So here A is going to be E. X, the power, is 0.1144t, and Y, what it's equal to, is 10. So use that to write this log form. Okay, so we're going to have log, and the base A is now going to be what A is equal to, so E, and then we have of 10 is equal to X, so it's equal to 0.1144t. Okay, and then you can figure out what log with a base E of 10 is. Okay, so to press E on your calculator, it's beside where pi is, it's in red. So we press the red alpha button to get to it. And we get that the left hand side here is equal to 2.3. Okay, so 2.3, and it goes on and on. So again, what I'm doing here when I'm writing down 2.3, I'm actually leaving the rest of the number on my calculator, so that even though I haven't written out 10 numbers after the decimal place, my calculator still knows what those 10 numbers are. Okay, but I need to divide this now by the 0.1144 so that I have t on the side by itself. So I'm getting rid of what's multiplying by dividing. Okay, so I'm dividing now by 0.1144 so that I have t on the side by itself, and on the left hand side I have 20.13. Okay, so that's what t is. So the question says to the nearest minute, so I'm just going to say 20 minutes is the time.